Woohoo! It's a great day to learn some geometry. I'm Miss Leg Battles, and I'm here today to talk to you about inscribed angles. So first of all, what is an inscribed angle? I have an illustration of one. Angle B is an inscribed angle in the first diagram. Its vertex is on the circle. The sides of the angle are chords of the circle. So the first thing we're going to talk about is the inscribed angle theorem. The inscribed angle theorem says that the measure of angle B is half the measure of arc AC. So the arc that we're looking at, this arc right here, AC, and angle B is the angle that's inscribed in that arc. So, for example, if this is a 90-degree arc, then this inscribed angle is going to be half of 90, which would be 45 degrees. You know, it's pretty easy to see that an inscribed angle would be smaller than a central angle. Let's look at what a central angle would look like. A central angle would have center, or the vertex would be at the center of the circle. We'll guess there, looks about there. So this pink angle would be a central angle, and its measure is exactly the same. So for example, if this arc is 90, then this is a 90-degree or right angle right there. And this angle, smaller than that one, it is a 45-degree angle. Now moving on, it says that the same rule applies if the angle is formed by a tangent and a chord. So it's still half the measure of its intercepted arc. So for example here, if we're looking for this angle, it is half the measure of its intercepted arc, and this is the intercepted arc. So let's say that's a 200-degree arc, then this angle right here that's formed by the chord and the tangent would be 100 degrees, half the measure of its intercepted arc. Now, let's move on to some corollaries. This inscribed angle theorem has three important corollaries, and I'm going to illustrate each of those for you. The first corollary says two inscribed angles that intercept the same arc are congruent. Well, you know, that makes sense to me. If they intercept the same arc and the inscribed angle's measure is half the measure of that arc, if they intercept the very same arc, they're going to have to be the same. So here I have an illustration of an inscribed angle, and I have highlighted its intercepted arc. So let's look at a different one. Let's have a different angle that intercepts the exact same arc. See, this green angle intercepts the same pink arc. So what this corollary tells us is that these two angles will have to be congruent to each other. Let's say this was a 40-degree arc. If that was a 40-degree arc, the pink angle would be 20 because it's half the measure of its intercepted arc, and the green angle would be 20 because it's half the measure of its intercepted arc. So that concludes corollary 1. Two inscribed angles that intercept the same arc are congruent. Now, let's look at the second corollary. An angle inscribed in a semicircle is a right angle. We know that a semicircle is a half of a circle, and its arc measure is 180 degrees. So here I have a diagram of a circle that's divided in half here. This angle is inscribed in the semicircle. In fact, let me highlight that. This angle that's illustrated has this intercepted arc, and that's half of a circle, so a semicircle, so it's 180 degrees. So it follows directly from the inscribed angle theorem that this would be a right angle if it's inscribed in a semicircle, because half of 180 is 90. Now, Let's inscribe a few others and see what that would look like. There's an angle that's inscribed in a semicircle. Here's an angle inscribed in that same semicircle. Here's another angle inscribed in the semicircle. I can't even draw them to make them look like they're not 90. If they're inscribed in a semicircle, they're half the measure of the intercepted arc. They're all going to be 90 degrees. So this one is 90. The blue one is 90. And the green one is 90. An angle inscribed in a semicircle is a right angle. Now, those two follow just directly from that inscribed angle theorem. Corollary 3 is going to take a little explanation. It says the opposite angles of an inscribed quadrilateral are supplementary. So here I have an illustration of an inscribed quadrilateral. See, every angle of that inscribed quadrilateral is an inscribed angle. And it says that the opposite angles are supplementary. 1 and 3 are opposite angles, so measure of angle 1 plus measure of angle 3 equals 180. 2 and 4 are opposite angles, so measure of angle 2 plus measure of angle 4 is 180. Now, that's pretty straightforward, but let's look at why that would be true. First, let's look at angle 1. It intercepts this arc. We'll do that in yellow. Then let's look at angle 3. It intercepts this arc. Now, I do not know the measure of the yellow arc, and I do not know the measure of the green arc, but I do know that when I add those together, I'm going to get 360 degrees because it's an entire circle. So, if the inscribed angle is half the measure of its intercepted arc, when I add these two inscribed angles, they would be half the measure of the total intercepted arc, which is 360. So half of 360 is 180. So the opposite angles of an inscribed quadrilateral are supplementary. Now, finally, I have 3 examples that I want to work through with you to illustrate these rules that we've talked about. First of all, in the first diagram, I see I have an inscribed quadrilateral. So I know that those opposite angles are going to be supplementary. So that tells me, for example, that C is going to be 180 minus 99. Because C is opposite from the 99-degree angle. So that's going to give me 81 degrees for measure of angle C. D is opposite the 113. So 180 minus 113, that's going to give me 67 degrees for measure of angle D. Next, let's look at this 113-degree angle. The arc that it intercepts is 96 and A together. So if the inscribed angle is 113 degrees, its intercepted arc is going to be, that's right, 226 degrees. It's going to be twice the 113, because this is the arc that 113 intercepts. Now, if I'm looking for just A, all I have to do is subtract. If the whole green arc is 226 and part of it is 96, A is the rest of it, the remaining part, which is going to be 130 degrees. Now, finally, I'm going to need to find B. So I notice that angle that's marked C, this one is 81 degrees. I found that earlier. It intercepts this arc. Let me highlight it in pink. angle C, which is 81 degrees, intercepts this whole arc, the pink arc, which is A and B together. Well, I just found out that A was 130. Okay, so if the inscribed angle is 81, then this entire pink angle would be twice that, which is, that's right, 162. So the whole pink arc is 162 all the way from here to here. So if A is 130, B is what remains. So that means B equals 162 minus 130, which is 32 degrees. Now, let's look at this next example. I notice it looks like the second part of the inscribed angle theorem because I have angle X that is formed from a chord and a tangent. Now, the first thing I notice is about Y. Y is going to be, it's going to be the remaining part of this circle. The blue arc is 232 and the red arc Y together make 360. So that means Y would have to be 360 all the way around the circle minus 232, which leaves me with 128. So this is 128 degrees. Now, Y is that it's like an inscribed angle. It's formed by the chord and the tangent. X is, I think I said Y, X is. So it's right here, this angle right here. So it is half the measure of its intercepted arc, and it intercepts that 128 degree arc. So half of 128, of course, is 64. So this angle X is 64. Now, moving to my last example, let's look back. Notice I found Y before X in the second example. In the first example, I found C and D before I found A and B. So when you work these problems, you do not have to go alphabetical. Even if on your practice exercises they ask for A first, you can solve for all of them. You do not have to find A first. You can find the others and then use them to find A if necessary. So, moving to the last example, I'm going to start with A. I notice that A is an inscribed angle. It intercepts this arc, and I already know its measure. So A is half the measure of its intercepted arc, which is going to be 26. Then for B, notice that B intercepts this arc up here. Well, I don't know what this arc measure is, but look what I do know. I do know that O is the center of the circle, so this right here is a diameter, cuts that circle in half. So what that means is that this arc right here is going to be 180 minus this 52 down here. So 180 minus 52 is going to give me 128. So this arc is 128. So B is going to be half the measure of its intercepted arc. So half of 128 is 64. And then finally C. C, notice, is an inscribed angle, and its intercepted arc is right here. Here's C. And so that is 82. So half of 82 is 41. Well, I hope these examples will be helpful to you. I sure enjoy doing this. If you notice, the color coding really helps because I think the hardest part of these problems is probably to isolate what you're looking for. And I did that easily with color. So break out your colored pencils, sketch your diagrams, and I'm sure you're going to do great on these. If I can do anything to help, let me know. It has been a great day to learn some geometry.